So, welcome. My name is Levi Moore from NC State, the Horticulture Department, and I'm going to be talking about evaluating the effects of herbicide applications as well as some other control methods to Palmer amaranth seed. So, a little bit about Palmer amaranth. I'm going to have several slides on Palmer amaranth. It's one of the worst weeds in the South. It's one of the worst weeds all over the country, but specifically in the South. It's got very vigorous growth habits. It's the worst weed in sweet potato production in North Carolina, which is what most of this is focused on, as well as other crops such as soybeans. Seen on the bottom there, there's a pigweed trial, very overwhelming. Up to 80% reduction in sweet potato yields has been seen, and 50% reduction can be from 1 plant per square meter. And this is the distribution of Palmer amaranth. It's most all over the country, but is the worst in the southeast. So, Palmer amaranth has high tendency to form resistance. So it's formed resistances to all of these listed: ALS, glyphosate is this one, as well as some others. PPO is the newest resistance that's being found that's going to be possibly the most problematic. Almost all Palmer amaranth in the southeast has ALS and glyphosate resistance, but the PPO is coming in fast behind. Whenever glyphosate resistance was found in Palmer amaranth, most people switched to controlling it with PPO herbicides, and so it's just a matter of time until it moves in. That's about half of the herbicide classes that's been found in, but the other half might not control pigweed, so we're running out of options for controlling this very quickly. There's some other classes that are good for controlling pigweed, such as the synthetic auxins like dicamba and 2,4-D, but for vegetable production, there's no GMO crops, so they can't really be used in season. No crop tolerances. So this is the genetic diversity that can be found. This is one I found in the field that I thought was cool. It had the seed head and then more leaves on the seed head, so that was strange. But usually it looks like the bottom right picture or that picture right there. And it's known to have these called watermarks on the leaves, but that's not even found on all of the plants, and they can vary in color. So large genetic diversity. And that genetic diversity is due to both the being dioecious, so there's a male plant on the right and a female plant on the left. There's actually a bee on the male plant. I thought that was cool. But that outcrossing increases the genetic variability that's in these plants, as well as up to 500,000 seed that can be produced with one female plant. So they're very vigorous. They're C4 photosynthesis, so they're better at competing with the crops than almost all agronomic crops we have. And they don't last the seeds don't last that long in the seed bank, so seed bank management can be a very good tool for controlling them, but since there's so many seeds, the seed bank can be replenished with just one plant in a field in 1 year. But the seed bank is a good way that can be controlling them. So a little bit about the study that that I've already done, sorry. I'm just gonna go through the materials and methods real quick. Got our massive tub of seed right there. We counted out 20 seed in each vial. We put the 20 seed in weigh boats, then we sprayed them with a bunch of different herbicides. This is a picture of the spray on the seed, and put them into petri dishes with filter paper to count how many germinate each day, and at the end measure the radical length. That was from those. Also, each herbicide that was put in was added with a crop oil surfactant, which can be seen on the right, which spreads out the water droplets, versus just water being applied. That's going to be really important in the later slides whenever I get into the data, because these probably had more water sucked into the seed versus some of these seed may have not had as much water actually sucked up into them, even though the seed were misted with water prior to let them suck up some more moisture. So this is the first day of germination, second day of germination, and that's the third day of germination. Very quick growth. And the third day is whenever we would measure the radical length. So at first we tried to use a digital caliper to measure radical length, but that was kind of silly. So then we started using the root scanner. So we placed the seed off of the petri dishes onto the root scanner, which takes a long time, so you gotta do it with tweezers. And you get a picture that looks something like this. And then using the WinRhizo software, that will measure each length and give a total length for the whole area that you're measuring. Whenever I actually measured them, it gave a bunch of different measurements, but those weren't important because I was just concerned with total length. I'm not sure what exact parameters it was set for, but it has a bunch of different colors in there. So total length is all I was concerned with. So this is day one. This is comparing, so I couldn't do the LSD test. So this is doing Dunnett's test, comparing each treatment back to either the control to the crop oil, which I'll get to in some later slides. But this is comparing the first day